So for example 3a, what we're going to do is I'm going to show that the linear approximation to this guy is equal to this guy right here. So what I'm going to start with a function. Now you have to pick a function from this so it's clear that we're going to be using the squared function. So what I've got is I've got a function f of x equal to x squared. And if we draw the graph for that guy out, looks something like that. And so let's say this guy is x sub naught. And we want an approximation of this guy over here, which is a little bit over. So what we want, x sub naught plus a little bit, f at x sub naught plus a little bit. That's the point. That's this point right here. What we're going to do is we're going to use this point right here. I'll do it in blue. We're going to use that point right there and its tangent line right here to get an approximation of the green point. So we're going to use the blue point to get an approximation of the green point. Well, what do we need to know? We need to know that the approximate change dy is our differential of y, and so this gives us the approximation, and so the approximation is going to be equal to the derivative at the original value times the change in x. So the derivative of the function f prime of x is equal to 2x. And so f prime at x naught is equal to 2x naught times delta x. Well, we know delta x is this distance right here. Okay, so that's that guy right there. And so what we can go ahead and we can do, give me 1 second here. So this dy is this distance, it's literally this distance right here, 2x naught delta x. That's this guy right here. But the total length up, the total approximation, I have to also add this guy. So this point, let me draw it in here. This point has a y value of the blue length plus the yellow length. Okay, and so that is going to give us, so dy, okay, it's just the little change in y, but the approximation is dy. So let me write this down for you. The approximation is equal to dy plus whatever the function was at this height. So it's going to be plus f at x 0. And we know that f of x 0, this height right here, since we're dealing with the squared function, this guy, f at x 0, is equal to x naught squared. So this blue one is equal to x naught squared. The yellow one is given right here, which is 2x naught delta x. And if we put them together, we get this point right here, which is a good approximation to this green point right here. So this is my linear approximation.